to start with the property a to the m times a to the n equals a to the m plus n. So the first example is, let me see, okay, good. The first example, it's kind of hard to read, is 5 to the 1/2 times 5 to the 3/2. So because you have the same base, what you do is you leave the base the same when you're multiplying, but you add those exponents. So we'll get 1/2 plus 3/2. Again, you're adding 1/2 plus 3/2, and that will make 4/2, which you can reduce to get 5 squared, or you can write your answer as 25. For this next example, we have 7 to the 1/8 times 7 to the 1/2. So since you have the same base numbers, we're going to add 1/8 plus 1/2. And in order to do so, you need common denominators. So we're going to times this fraction by 4 over 4. So you end up getting 1/8 plus 4/8. And when you add that together, you get 5/8. So here, when we go back to the original problem, again, 7 to the 1/8 times 7 to the 1/2, when you're multiplying same base numbers, you leave the base the same, and then you add those exponents. So we already did that over here. So you get 7 to the 5/8. And you can't simplify that any further, so you would just leave your answer like that. So same base numbers, we're going to add the exponents, 1/4 plus 1/2. And again, if you want common denominators, you're going to times by 2 over 2. So you get 1/4 plus 2/4. And when you add those, you get 3/4. 16 to the 1/4 times 16 to the 1/2. We're going to leave the base the same as 16. And you add those exponents, which we did the work over here, and you get 3/4. So this simplifies further, 16 to the 3/4, because the bottom number in the fractional exponent is a 4. That's the same as the 4th root of 16. And again, I kind of use this as the analogy of a tree. So on a tree, your roots are at the bottom of the tree. Obviously, leaves are at the top. So like the fraction 3/4, 4 is on the bottom of the fraction, so that's going to represent the root. So it's the 4th root of 16, and then that 3, you need to bring it down as an exponent, and then you can just take the 4th root of 16, so you're asking yourself what times what times what times what is 16, which it's 2, but you're still going to cube that answer, so your final answer is 8. 32 to the 2/5 times 32 to the 1/5. So leave the base number the same and add exponents. So 2/5 plus 1/5 would make 3/5. And just like the last problem, this is going to simplify further. The 5 represents the root, and 3 is going to be left up top. So we're going to go 5th root of 32. But you still have that exponent to the 3rd power. So the 5th root of 32 is 2, and then cubed is going to make a total of 8. Okay, our next property is a to the m to the n, and so when you have exponents to exponents, you're going to multiply the exponents, so that's why this equals a to the m times n. So on this next example, it says, simplify 3 to the 3/2 all raised to the 2nd power. You're going to multiply those. So on the side, just in case you need to see it written out, 3/2 times 2. If you need to multiply those, you can put the 2 over 1, and then when you're multiplying fractions, if there's anything on top and bottom that can cancel, go for it. Makes it a lot easier to simplify. So all that's left is 3 on the top and 1 on the bottom, but 3 divided by 1 is just 3. So this exponent up here, when we multiplied it out, we got 3. So you get 3 cubed, which ends up just being 27. Exponents to exponents, we're going to multiply. So you have negative 5/11 times 11 over 15. And you can see that the 11 is on top and bottom, so those both cancel. So now you have negative 5 over 15, which reduces because you can divide both by 5. So if you divide the top by 5 and the 15 by 5, you're left with negative 1/3. So one of your other properties says that if you have a negative exponent, you can move this term, either if it's on top of a fraction, it moves to the bottom, or if it's on the bottom, you move it to the top. So right now, we're going to move the 8 to the bottom of a fraction, making the 1/3 become positive. When you do so, it leaves a value of 1 on top. And then we just have to do one last step. This represents the cube root of 8, so the cube root of 8 is 2. So you end up getting 1/2. So last one in this section, we have 1/25 raised to the -4/7, all raised to the 7/8. So same thing, you have exponents to exponents, so we'll write -4/7 times 7/8 to multiply those exponents. And you can see the 7's cancel. And now you're left with -4/8, which reduces down to -1/2. So we're going to write this as 1/25 all raised to the -1/2. So another thing, when you have a negative exponent, if there's a fraction, it flips the fraction. By flipping the fraction, you make that exponent positive. And again, you can only do that if you have a negative exponent, because essentially it's like if you raised 1 to this power and 25 to this power, they would both have negative exponents, so they would switch places. The 25 would go to the top, the 1 would go to the bottom, which is the same as just 25. 25 to the 1/2 is the same as square root of 25, which just equals 5. Okay, the next property we're using is a to the m divided by a to the n. When you have a fraction with same base numbers, you subtract the exponents, leave the base the same. So we're going to work on that in just a second. But first, in this first example, it says simplify. This is x to the 3/8 times x to the 1/4 all over x to the 1/8. So the first thing I want to do is just work on the numerator. Again, when you're multiplying with same bases, you add exponents, so I want to clean that up first. So we're going to add 3/8 plus 1/4. To do so, we're going to get common denominators, so we'll times this by 2/2. So you get 3/8 plus 2/8. So that'll make a total of 5/8. So the numerator is going to be x to the 5/8 over x to the 1/8. So now we can apply the property that I was just looking at. When you have a fraction, you're going to, with same base numbers, you're going to subtract the exponents. Now, kind of a nice little thing to look at is which exponent is a larger value. So if you look at this exponent, it's 5/8. That's going to be more than 1/8. So whichever one has more, then that's where you're going to put your answer. So again, 5/8 has more, so your answer is going to go up top. 5/8 subtract 1/8 is 4/8, and again, you put it on top. Now if the 5/8 was on the bottom and the 1/8 was on top, you would put this on the bottom. It would be 1 over that. But it's not, so we'll keep going. Reduce your fraction and you get x to the 1/2. Or you could also write it as square root of x. Either one is fine. Alright, so here we have 3 to the 5/2 times 3 to the 1/2 all over 3 to the -2. So similarly, like the last couple of problems, we're going to look at the numerator first. Same bases, so we're going to add those exponents. So 5/2 plus 1/2 is going to equal 6/2, which is just 3. Be 3, and this simplified to the 3rd power. You still have 3 to the -2 in the denominator. So here you have same bases. The base number is 3. This 3 on the bottom has a negative exponent, so we're going to move this base number to the top. 3 cubed times 3 squared, add those exponents, so you get 3 to the 5th. You could leave it like that, or you could multiply that out, which ends up being 243. 5 to the 5/6 over 5 to the 1/6 times 5 to the 1/2. So this time I'm going to work in the denominator. 1/6 plus 1/2. To make common denominators, we'll times by 3/3. 1/6 plus 3/6. And so that's going to make a total of 4/6. Now normally I would simplify this, but looking back to this problem, in the numerator you have 5 to the 5/6. In the denominator we simplified and got 5 to the 4/6. Now leaving this as 4/6 is going to be helpful here because now these fractions have the same denominator. So you have 5/6 versus 4/6. So you can see that this exponent is larger. So when we work this out. You leave the base the same, and you subtract 5/6, take away 4/6, makes 1/6, and you put that answer on top because originally this was bigger. And then we'll just leave that answer just like that. Now we're going to simplify with radicals. So we have the square root of 75x squared y to the 5th z. 75 would be 3 times 25 3/4, and then 25 is 5/5. So you can break it all the way down, or you can stop here where you have a perfect square. Whatever makes more sense to you is great. So let's see. 75 became 3 times 5 times 5. This is a square root. It's implied that there's a little 2 right here. So we just don't write it because we all know it's just a square root, but it's implied that there's a 2. So the way we're going to break down these variables is we're going to say 2 goes into 2 how many times? The answer is 1, so then you're going to write x to the 1, x to the 1. Okay, we're going to do that also with the 5. So 2 goes into 5 how many times? The answer is 2. So what we're going to do is we're going to write y squared, and we wrote the answer y squared twice, again because of the square root, but there still is 1 left over to make a total of y to the 5th. And then we're just going to drop down this z. And so on a square root, you can pull things out when they're in pairs. So when you take 5 times 5 out, it turns into just the number 5 on the outside. When you take this x and x out, because you have a pair of them, it turns into just one of them. Same thing here, you have y squared, there's 2 of them, they come out because they're a pair, but when you pull them out, it turns into just one of them. So instead of, again, y squared, you pull it out of the square root, and now it's just y squared. And then everything that's left, you just leave it underneath the radicals. We'll go 3yz, and that's going to be your final answer. 5x y squared times the square root of 3yz. This is cube root of 16x to the 6th y to the 5th. So again, if you need to break it down, because that helps you, we would break 16 to 2 and 8, 2 and 4, 2 and 2. So you can see all the broken down factors. So cube root, and again 16 was 2 to the 4th. Okay, so now we're going to do that same questioning again. We're going to say 3 goes into 6 how many times? The answer is 2. So that's going to be the exponent. So we're going to write x squared, and we're going to write that 3 times because of this cube. So again, the way I did that is I said 3 goes into 6 how many times? The answer is 2, and that's the exponent, so x squared. Like this was a cube root, so that's why we wrote it 3 times. So same thing if you said 3 goes into 5 how many times? The answer is 1. So 1 is the exponent, and then you write it 3 times, and then you have to make sure you know how many are left over, so that would be y squared is left over, so that you can pull things out in triples this time. So you have 3 2's, you're going to pull them out, they turn into just 2 on the outside. You have x squared, 3 of them, so they come out of the cube root, and you're left with just an x squared on the outside. These y's come out, and they turn into just y on the outside. And then you write whatever's left on the inside. Make sure you write it as cube root of, and what do we have? A 2 and just y squared. So your answer is 2x squared y times the cube root of 2y squared. The 4th root of 625, a to the 5th, b to the 8th, c to the 12th. So this one's going to break down a lot. So again, you can use your calculator or start breaking it down, but it's 25 times 25. You have 5, 5, 5, 5. Next, 4 goes into 5 how many times? The answer is 1. So you're going to write a to the 1, and you'll do that 4 times. 4 to the 1, 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 4 to the because of the fourth root right here, and then you have to ask yourself how many left over, so that's just another a. 4 goes into 8 how many times? The answer is 2. So you're going to write b squared, again because you asked yourself 4 goes into 8 how many times? The answer was 2, so that's the exponent, and then you write it this many times, b squared, b squared, b squared. I'm running out of room, so we'll squeeze it in over here. 4 goes into 12 how many times? The answer is 3. That's the exponent, so we'll go c cubed, c cubed, c cubed, c cubed. Now we're going to pull things out in sets of 4. So these 5s come out, and they turn into just 5. The a's come out, turn into just a. The b squareds come out to the front, and they turn into just b squared. Same thing with the c cubes. And you're left with just a underneath the fourth root. So your answer is 5ab squared c cubed, fourth root of a. This last property, it says the nth root of a over the nth root of b equals the nth root of a over b. So as long as these are the same roots, even though they're different base numbers, you can rewrite it as one big fraction with that root on the outside. So we're going to do that property, use that property on these examples. This one says simplify. It's square root a to the 9th b to the 5th over square root a to the 5th b. So we're going to write it as one big square root a to the 9th b to the 5th over a to the 5th b to the 1. And then now that it's in here, we can now simplify. You have a quotient with a's, so you're going to subtract 9 minus 5 is 4. And because there was more on top with the 9, then you're going to put your answer as a to the 4th on top of the fraction. Same thing here, I'm going to fill in 1. 5 minus 1 is 4. 5 was more, so you put the answer on top as a 4. And so there's no longer a fraction because both terms ended up going to the top. Now we're just going to simplify this. This is again a square root, so you're saying 2 goes into 4 how many times? So that would be twice, so you'd write a squared, a squared. Same thing for the b's. And you can pull them out in pairs. So there's your answer, a squared, b squared. You have cube root of x to the 7th, y to the 12th, and divided by cube root of x to the 4th, y to the 6th. So because it's both cube roots, we're going to write it as one big fraction. So it's x to the 7th, y to the 12th over x to the 4th, y to the 6th. So we can reduce this fraction. The x's, same thing. 7 minus 4 is 3, so there's more on top, so we'd write x to the 3rd on top. 12 minus 6 is 6, and there's more on top, so it's going to be y to the 6th. And finally, cube root, let's break it down. 3 goes into 3 once, so that's your exponent, and you write it 3 times. 3 goes into 6 twice, that's your exponent. Write it 3 times, and now you can pull things out in triples. So the x's come out, the y squareds come out, and there's nothing left under the radical, so this is just your answer, xy squared. Here it says 5th root of 8 times 5th root of 16 over 5th root of 4. One big fraction, 8 times 16 over 4. So at this point, reduce your fraction. I'm going to reduce the 8 and 4. Again, you could do this any way. You could reduce either. So you get 2. So you now have 5th root of 2 times 16. So that would make 4 2's. So in total, you have 5 2's. They all come out and turn into just the number 2.